You get a fresh data set, and the urge is immediate. You want to open it up, plot distributions, check correlations, and start building charts. It feels productive. But then you hit what analysts call the EDA spiral. You add one breakdown, check one more variable, and suddenly hours have passed. You have a pile of interesting observations, but zero actionable answers. The mistake here is jumping straight into the rows and columns without defining exactly what you are trying to prove or disprove. To fix this, you need a testable hypothesis, a strict compass that tells you exactly where to look, and just as importantly, where not to look. So before you write a single line of SQL or open your dashboard, close it. Start with a blank page and a broad business problem. Intent has to come before exploration. Without a clear expectation of what you want to find, the data will only generate noise, not decisions. Step 1 is translating your broad research question into a specific driver. A question or a vague guess is an open-ended thought. A hypothesis is a concrete expectation. It is a statement that can actually be measured and then confirmed or rejected. Let's look at a coffee shop with a struggling loyalty program. The business is asking, why is participation so low? That question is too big to test all at once, so we break it down into possible drivers, and we isolate just one to start with. Older customers prefer cash. By stripping away all other variables and focusing entirely on a single logical driver, you make the business problem measurable. To build your hypothesis, use this template. I believe blank affects blank because blank. First, define the relationship. For our coffee shop, I believe age affects loyalty participation. Next, add the business logic, because older demographics prefer cash and avoid apps. Forcing your assumptions into this written structure exposes them clearly on the page. Now, the data has something specific to challenge. Now that we know what we expect to happen, we have to turn that idea into a strict action plan. We finish the sentence by specifying the exact methods. I will test this by segmenting customers by age and comparing app usage and transaction methods. Look closely at those words: age, app usage, transaction method. These correspond directly to the physical columns you will need to query in your database. If you read your sentence and you cannot mentally picture the actual tables or data points required to prove it, your test is too vague. You need to rewrite it until the metrics are obvious. Once complete, this sentence acts as an absolute boundary for your work. It tells you exactly which data you need to pull and strictly dictates which data you need to ignore. You have a written plan, but before you touch your analytics tools, you need to validate it mathematically. First, do you know what decision this analysis supports? And second, is it genuinely testable? Third, do you know exactly which variables matter? And finally, do you actually have the data needed to confirm or reject it? A quick note here: resist the temptation to group multiple ideas together. Testing too many drivers at once will completely derail your focus. Stick to one at a time. If your answer to those 4 questions is yes, you are ready to begin. Passing this checklist anchors you to a single, verifiable goal, which stops the endless exploration spiral from happening in the first place. Think about the difference. You started with a vague worry about low loyalty numbers. Now you have a highly specific, data-ready action plan. Now, and only now, you can open your dataset and begin your analysis. Your job isn't to fish for random insights anymore. Your job is to ruthlessly let the data confirm or reject the sentence you just wrote. Take this exact framework and apply it to the project sitting on your desk today. Write down the relationship, explain your reasoning, and define the test. Putting the hypothesis first takes the guesswork out of the process. It turns your time in the database from aimless exploration into reliable, purposeful decision-making.